Hello everyone, my name is Bruce, and this is my second video on statics. This is force systems and a three-dimensional problem. So we have tension is equal to 2.4 kilonewtons, and that is on AB. So I'll just add that in to the free-body diagram, sort of, there. And they want this tension as a vector expression. So that means they want it in I, J, and K. And they also want the rejection of T along the line AC. So they want it right along here. So they want you to project it across that. So how do we do this? Well, in the last video, we said that tension, or the force, is equal to the force times the unit vector. And the unit vector in this case is going to be from A to B or B to A. Depends on which direction the tension's going in. So I probably did that wrong, but whatever. Doesn't really make a difference. So we start out with the x. So the unit vector is equal to 2 in the x. So that's 2I. And that's going to be 1 because it goes across 1 here. And that's going to be plus, actually minus, these are both going to be minus. That's going to be minus j, and then it's going to be plus 5k. And you can see that because the tension is going up in this direction, which means it's going to be going a negative x, a negative y, and a positive k. And then we do that all over the square root of each of them squared. So just 4 plus 1 plus 25. And that's going to give us, so that's what this gives us for the unit vector from A to B or B to A, in that term. So that's that, and then to get the tension in terms of the vectors or whatever, in terms of I, J, and K, we simply have the tension is equal to 2.4, and that's going to be the dot product of negative 0.365 I minus 0.183 J plus 0.913 K. So we have, okay, so let's just look at this in review. And it seems like I made a little mistake. It should actually be, let's see here, it won't affect our numbers too great, but, I'll make this blue. The tension should actually be facing down, because we are going from A to B, and therefore it means that from point A to point B, it's going to be increasing along these values, so these should be positive, and then this should be negative. So the only way that that's going to change our stuff is it's going to make this a positive, positive, and I will try to get rid of that. Okay, that always seems to do that. I'll just, there we go. That's a negative. Okay, so that's what we get. And that's the tension. And does that make sense why it should be like that? Because it's going from A to B and not from B to A. So that's the tension. So how do we get the projection from AB to AC? Well, we have to take the tension is equal to, well actually no, we will take the projection. So we'll have projection is equal to the tension, which is the unit vector, the vector tension. And we're going to dot product it by the unit vector from A to C. And the unit vector from A to C, which would be NAC, is equal to, so it's going from A to C, which means it's going to be a negative value. So that's going to be negative 2, oh, Actually, that's J, actually. For the x, it'll be positive. It will be 2I minus 2J minus 5K. And then that's all going to be over the square root of, what's that, 4 plus 4 plus 25? And I'll just quickly compute that out. Okay, and that's what we have for the unit vector from A to C. And then we simply just have to multiply it out. So we have projection equals this value there, 0.876i plus 0.4392j minus 2.19k, and then that's going to be dot by 0.348i minus 0.348j minus 0.87k. So the scalar projection is 2.06 kilonewtons. And that's how you solve the problem. So let's just quickly review what we just did. We started out with the buckle being tightened, and it's causing a tension, and that would be going down, like that, and not that, scratch that. And essentially we need to break it down into a vector, which is just I, j, and k. So in order to do that, we multiply it by a unit vector, which I will just go over with the highlighter. So you have to do the unit vector, which is this, and that comes from over here. And then from there, after we found the tension in a vector, which is this guy here, then we plug it in here, and we need to multiply it. For the projection, we take the tension of the cable going across here, multiplied by, well, dot product by the unit vector of AC, which is there, and then that unit vector is this value here. Well, that's how you solve it. And then you just multiply them out, and that will give you your final answer, which is there. Okay, thank you for watching my video. Please comment. Constructive criticism is appreciated. So thank you for your time, and have a nice day. Hello everyone, my name is Bruce, and today we're going to be doing another statics problem. And this one it's from chapter 2, which is for systems, and this is a three-dimensional problem, as you can see. The problem asks, express f as a vector in terms of unit vectors I, j, and k. Determine projection both as scalar and as a vector of f onto line OA, which lies in the xy plane. So, we need to find f as a vector, so we'll start off by doing that first. And they give us these values here, the angles. So we'll just say f equal to f times the n, which is the unit vector. So this is essentially f is equal to f dot n. There we go. So, sorry about that. It's the finicky touchscreen laptop. Okay, so we start out with x, so it's going to be in the negative direction, so it's going to be negative, what's that sign, 35? Oh, tricky. Actually, you notice here, that would be if we had the force going across the bottom here. So we'll first have to find this f, which we'll call fxy, and that's going to be equal to the cosine of 50, because we know that this angle here is 50. So cosine 50 It's going to be times f. And fz is going to be f sine 50. And then we split the fxy into x and y components again. So that's just going to be from this line here. So the x component is going to be, I'll write it in red here. X is going to be like this, and the y, being blue, is going to be like this. So, keeping up with the whole red theme, fx is equal to this cosine 50 times sine 35. And in blue we have fy, and that's going to be equal to f cosine 50 cosine 35. And these are actually both going to be negative, but we won't worry about that right now. I'm getting a phone call. Sorry about that. Okay, sorry about that. So we have f of x, which would be negative cosine 50 sine 35. We're running into this, and that's an I. And let's see, j would also be negative, so negative cosine 50 cosine 35. This is running on a little bit. And then that's going to be positive, so plus sine 50. Not cool. Okay, there we go. That sort of ran on a little bit, but it shouldn't be too difficult to solve, seeing as F is 5 kilonewtons. So, just plugging in the numbers, I'll just do that quickly. And whoops, a little mistake there is actually the y's are going to be positive. Just remember that. So yeah, this is what we get for the F in terms of the unit vectors. So now we have to find the projection both as a scalar and a vector of F onto line OA. So we simply go projection is equal to F dot NOA. Okay, there we go. So, and that will give us a magnitude, which would be the scalar. So we'll have negative 1.84 I plus 2.63 J plus 3.83 K, and that is the F unit vector, and that's going to be dot. Now for this, all we have to do is we just say that A is going to be in the XY, which means there's 0 K. So we have for the X is going to be cosine 30. And then for the Y it's going to be sine 30. Again, sorry about that. Let's see here. And I'll just quickly multiply that out. And that is what we get there. Yeah, so that's what we have right now. And this is just the magnitude, as I said before, the scalar. So to convert it into a vector, we simply just say F, OA, or projection, or whatever. And that is going to be this dot the unit vector, which is just going to be the same exact thing. So we're just going to have negative 0.278 dot cosine 30 I plus sine 30j, and that will give us, and it'll give us that. Just multiplying it out, and that's basically how we solve it. So the key things to remember are as f in unit vector terms, f in a vector, I, j, and k, you just multiply it by a unit vector. Unit vector is just the distances or the angles, whatever you want to think of it. And then for projection, you just are multiplying it by the unit vector of the line that you want to project it onto. And that's pretty much it. So that's your answer, and you can check it, and check out some of my other videos.